Hello, my name is Angelo Guarino,
My name is Austin Martini.
I'm Maddie Minear.
I'm Thomas Dietz.
And I'm Zach Sauerwein.
and we represent vehicle number 3 from the University of San Diego.
Our team designed a vehicle with a tadpole configuration with 2 front wheels connected to the steering and 1 rear wheel connected to the drivetrain to power the vehicle. Each wheel has an integrated disc braking system to stop the vehicle in the required distance. We also designed an adjustable seat, which allows for different size riders to pedal the vehicle and replaces the chain gobbler, reducing weight and chain complexity. In the steering design, we implemented direct steering, where the handles are directly connected to the kingpin and then the wheels. Ackerman steering was also implemented into this design. This causes the inside wheel to turn more than the outside wheel and allows for tighter turning radius as well as more stable and easier steering.
When using FEA on the roll protection system, the top load caused a deflection of 9.56 millimeters, the side load causing a deflection of 1.17 millimeters, and the factor of safety ended up being 1.56. And this was all using 4130 chromoly steel with a tubing size of an outer diameter of 1.5 inches by a 0.065 wall thickness. Using the physical load testing and this FEA method on the 2019 vehicle, we can estimate the deflection we should see in the physical load testing of the 2020 vehicle. These came out to be 12.88 millimeters from the top load and 9.56 millimeters from the side load. When access to our university's machine shop has been granted again, we will perform the physical load testing on the 2020 vehicle to verify the analysis and calculations.
We also used safety analysis to find the drag force and the drag coefficient for both the 2019 and 2020 vehicles. Comparing the two trikes, it was found that the 2020 trike has 20% less drag than the 2019 trike.
After using this analysis to fine-tune our design, we dove into manufacturing. About 90% of the frame has been manufactured before the university machine shop closed due to the COVID-19 outbreak. The last steps are to integrate the rear triangle shown in the far left picture using our laser cut jig. The seat attachment points were almost 100% complete. The upper seat attachment just needs to be cut down to size, shown in the middle column of pictures. And the drivetrain is about 75% complete, as train routing still needs to be designed. But the rest of the drivetrain components, such as the bottom bracket and dropouts, shown in the far right pictures, just need to be integrated with the rest of the frame.
For the steering side of things, we are happy to state that we have been able to manufacture all of our key components. The first key component we manufactured was the knuckle. For this process, we used the CNC machine due to the complex geometry and angles. The next key component we have finished was the brake bracket. This was done by hand using the mill. We were also able to finish the axle, which allowed us to put all 3 of these key components, including the wheel, brake caliper, and brake disc. This assembly is shown to the picture to your left. We were able to confirm that all these parts fit properly, confirming that our braking mechanism works. The last key component was the control arm. Although this is a simple part in comparison, it was a key component for the steering geometry to make sure we achieved acronym steering. And this was confirmed, which you can see on the picture to your right. Non-key components that we have manufactured include the tie rod plugs and the axle plugs. Pretty much what is left to do with the steering manufacturing is to cut to size the steer tube, head tube, and our carbon fiber tie rod tube. And beyond that is just assembly and welding.
There were 2 performance tests conducted to establish a benchmark to scale the 2019 versus 2020 vehicles in competition-like scenarios. These have been included to ensure design improvements from past years, as well as scale the physical performance in lieu of no longer having a physical competition. The test planned to be performed upon completion of the manufacturing of the 2020 vehicle. The first one being a speed trial test to duplicate the drag race event. Time trials were taken between 2 landmarks to get a baseline comparison of top speeds and times. Completing this test also gave a better understanding of the importance of gear ratio, chain routing, weight reduction, and comfortability and adjustability.
The second performance test that was done was the turning radius. This test was done to confirm that the bike could make a 180-degree turn within an 8-meter radius, which was a constraint within the HPVC rulebook. With last year's bike, this test showed a phenomenal turning radius of 2.5 meters when taken at a speed of about 4.5 miles per hour. The importance of completing this test was to help the team understand the importance of acronym steering being implemented into the steering geometry, something last year's and now what we believe this year's bike was able to accomplish.
In conclusion, the team's manufacturing of a bare bones rolling vehicle is estimated around 85% at the time of submitting this design presentation. The team hopes to still be able to complete the vehicle after either through the opening of the university in the future, and if not, through the request for quotations from a third party. The objectives have remained the same, and that's to design and develop a human-powered vehicle to compete in the 2020 ASME competition, while demonstrating design advancements from past USD human-powered vehicle entries. Thank you for listening.